My name is Alpana Barman, Assistant Professor of Electrical Engineering Department of Haldia Institute of Technology. Today I am going to discuss on static characteristics of measuring instruments. Now, whenever we are going to perform any kind of experiment, we have to use different kind of measuring instruments, such as for the measurement of current we have to use ammeter, for the measurement of voltage we have to use voltmeter. Now, how these instruments are working, is it working properly or not, that we can see from the static characteristics of the measuring instruments. So before going to perform any instruments, we should know what are those characteristics or behavior of the measuring instruments. The set of criteria defined for the instruments which are used to measure the quantities which are slowly varying with time or mostly closed. That means the static characteristic is that one which is not varying with respect to time. It will be everywhere fixed for the specific instrument. Now, what are those static characteristics? Here it is written: accuracy, precision, resolution, speed of response, repeatability, and reproducibility. These are all some static characteristics of a measuring instrument. Now let's try to understand what is the meaning of accuracy. It is the closeness with which an instrument reading approaches the true value of the quantity being measured. Try to understand this accuracy with the help of one example. Let we have one resistance, this resistance, let R1, and we are asked to find out how much current is flowing through this resistance. So for this measurement we have to connect one ammeter in series with this resistance, and let for this ammeter 1 the value is coming 5.2 ampere, whereas let the current which is actually flowing through this R1, that is 5 ampere. Similarly, for this measurement we are going to use another ammeter. This is let A2, and for this A2 ammeter the value is coming let 5.05 ampere. So here from this example we can say A2 ammeter, this one is more accurate compared to this A1, because the value, this 5.05 ampere, is very nearer or close to this true value, which is 5 ampere compared to 5.2 ampere. So this is called accuracy. Now try to understand what is the meaning of precision. Precision refers how close together a series of measurements are to each other. That means here we have to perform one experiment but in several times to get a series of unknown values. So same example here, this is the resistance R, and let the true value of current which is flowing through this resistance, that is let 5 ampere. Now with the help of this ammeter 1 we are going to perform this experiment, but several times we are going to perform. And for first experiment let the value is coming 4.8 ampere, then 4.9 ampere, 4.95 ampere, and let For fourth number of experiment is coming 5.05 ampere, 5.1 ampere. So this is a combination of this experiment with the help of ammeter 1. Now same experiment we are going to perform with the help of another ammeter. This is let ammeter 2. And here same number of experiments we are going to do, and for each experiment the value of unknown parameter is coming. Let 4.6 ampere, 5.3 ampere, 4.75 ampere, 5.35 ampere, or 5.4 ampere. So here we can see that for ammeter 1, the values, all values are very close to the true value, where true value is 5 ampere. But for ammeter 2, the values which are coming, these are not nearer to true value. These are random values, which is 4.6, 5.3, 4.75. These values are not very nearer to the true value, where true value is 5 ampere. So from this example we can say this ammeter 1 is more precise instrument compared to this ammeter 2, where the series of this measurement is very nearer to the closed value, to the true value. So ammeter 1 is more precise or sharp compared to ammeter 2. Now, what is the meaning of resolution? Resolution of any instrument is the smallest change in the input signal which can be detected by the instrument. Now, I am going to explain what is the meaning of the resolution of any kind of measuring instrument. Let this is the ammeter, where the range of ammeter is 0 to 10 ampere. This is an indicating device. So there is a pointer which can move towards this scale. And this scale is calibrated like this. Let this is 1 ampere, 2, 3 ampere, like this it will be up to 10 ampere. Now supply is given. Let switch is on, and this ammeter is connected in series with the resistance R1, through which we are going to find out the value of current. Now let the value of current which is flowing through this R1, that will be 5 ampere. So what to do? This, when switch is on, this pointer will start to move towards this direction, and it will be damped where at this 5 ampere value of ammeter. But that can be easily shown by this meter, fine. But when we want to measure the value of current, which may be 0.5 or 0.2 ampere. So is it possible to measure exactly 0.2 ampere current? Whereas the scale is calibrated like this. The first value of this one is 0, Then second segment that is at 1 ampere. Third one that is at 2 ampere. So the division between 2 points that is your 1 ampere. But when we are going to measure the value of 0.2 ampere current with the help of this ammeter, we are not exactly able to find out the exact value of this one, because there is no that kind of segment which will give us exactly 0.2 ampere current. So the resolution of the meter that will be good or applicable for the measurement if we choose a proper instrument where the meter will be calibrated properly. The smallest change we can able to detect to measure the unknown parameter. If we have this kind of instrument where it is calibrated like this is 0, then this one is let 0.1, 0.2, 0.3, then we can easily measure this value of unknown current, which may be 0.1 ampere or 0.2 ampere. So for this ammeter, we can say the resolution of this ammeter 2 is good compared to ammeter 1. This is the basic difference between this ammeter 1 and ammeter 2, where with the help of this example we can say ammeter 2, for this ammeter 2 resolution is good compared to ammeter 1, which is the smallest change in the input signal can be detected by the instrument. Next, what is the meaning of speed of response? So it is the quickness of the instrument to measure the unknown parameter is called the speed of response. Let we want to measure the voltage of the unknown parameter, the voltage of the resistance, let R2 or R3. So we have to use one voltmeter. So how much time will be taken to give us the value of the unknown parameter, that will define the speed of response for the specific instrument. Now, what is repeatability? It is defined the degree of closeness in which input quantity is measured several times for a set of readings of an instrument, considering all environmental conditions are constant. Here we are using same methods for the measurement, but we are giving several values for the unknown parameter, and every time for each and every experiment we have to check whether the unknown values are nearer to true value or not. But for each and every experiment, the environmental condition that will be remain same. Now, what is reproducibility? It is defined the degree of closeness in which the unknown parameter is measured using different methods but random in nature. So here we are going to perform one experiment but with the help of several methods. And each and every time we have to check the unknown parameter which are coming from those experiments are nearer to true value or not. And every time the nature may be changed. Okay, now the instrument which has repeatedly characteristics in good condition and also reproducibility characteristics in good condition, then we can say that instrument is more precise. Okay, now how many type of errors may introduce in a measuring method, in a measurement system? First one is absolute error and second one relative error. What is absolute error? It is defined the difference between the true value and measured value, which is denoted by delta A. Let the current which is flowing through the resistance, that is actually 10 ampere, and after the measurement it's coming late, is coming late 9.5 ampere. 9.5 ampere. So the absolute error will be 0.5 ampere. Okay. And what is relative error? It is defined. What is the difference between true value and measured value with respect to the true value? Actually, this relative error is represented in percentage form. So, percentage form of relative error, which is denoted by epsilon r, that is the difference between true value and measured value with respect to true value with the multiplication of 100%. This is called relative value, relative error. Now, why these different kind of errors are introduced when we are going to perform any kind of experiment? The sources of these errors are can be classified or can be explained with the help of these three kind of points, which are gross error, systematic error and random error. Now under this gross error we have three different points for which we are not getting the measured value nearer to true value. First one is the position of the pointer. When switch is off, for any kind of indicating instrument, the position of this pointer that should be at 0. And when switch is on and this ammeter is connected in series with the resistance or with the inductor, what will happen? This pointer will start to move from its 0 up to maximum value according to the unknown quantity. Now, if the position of this pointer is not exactly at 0, somehow it is late, like this. It is late like this. Then what will happen? When switch is on, we are going to perform this experiment with the help of this meter. This pointer will start to move from its position and it will be like this. It will be like this. That means this is the difference. Instead of 0, it will start from this position. And obviously for 5 ampere current, we are getting late something 5.2 ampere. So this 0.2 ampere, it will be the difference between the measured value and true value. Now, point number 2 under this gross error, that is if the pointer deflects between the two scaling points. That is what? Let the instrument which we have chosen for the instrument, it is calibrated like this: 0, then 1 ampere, 2 ampere, 3 ampere. In such way it will be up to 10 ampere. Okay, and when switch is on, the unknown value of this current, that is somehow this. So here As the resolution is not that much good for this ammeter, we are not able to take the exact value of this unknown quantity. It may be 0.8 or maybe 0.85, maybe 0.87. So it is not exact value which we are going to find out. So here we have to uh, consider, we have to assume, okay, as it is in between 0 and 1 ampere current, so it may be 0.7 or 0.8, which is not exact value of the unknown quantity. That's why there will be some error. And number 3 is, which is called parallax error. Parallax error means always whenever we are going to take the reading from the indicating instrument, the instrument should be placed vertically and we have to see perpendicularly to take the readings for the instrument. Okay, if we are not going to all these things, then obviously there will be some difference between true value and measured value. Now, systematic error, that is dependent on where we are going to perform that experiment. That depends on the temperature, humidity, pressure, etc. And also due to the carelessness of the observer. Now, random error, that is actually subjected to irregular. We don't know why uh, there is some difference between this true value and measured value, but always when we are going to perform any kind of instrument, we'll see that there are some difference between the true value and measured value, and the reason why we don't know, due to that we call it as random error. So today that's up to you. So far we have learned what are the static characteristics of the measuring instruments. Then then we have learned what is absolute error and relative error, which we basically used to do in our measurement labs. Okay, and then why these different kind of errors are introduced for any kind of measurement system. So those are classified in 2 3. One is gross error and systematic error, and third one is random error. And gross error again classified into different categories. First one due to the position of the pointer. Second one is the points between two scaling points, where our pointer is deflecting what the calibrated scale. If it is not specified by the manufacturer, if we are not going to able to choose the proper instrument for the instrument, then we have to face this kind of error. And third one is parallax error. Always we have to see the value of the unknown quantity perpendicularly. Okay, and systematic error, that depends on the environment, and random error is subjected to irregular. And next day we'll do some numericals based on absolute error and relative error, and also we'll do some numericals based on resolution. After that we'll start another topic, that is AC bridge. Thank you.